today we're going to build a CDN in under an hour. And this will be very much like a cooking show in which we end up with something nice. Most of it is done live, but some things are prepared in advance. That's the only way it will work. Anyway, I am Thijs, as I was introduced, and I am the Technical Evangelist at Varnish Software. Now, it's already been told that Varnish Software is the company behind the Varnish Cache open source project, but we also have a commercial version called Varnish Enterprise that builds on top of Varnish Cache, and I will use Varnish Enterprise in this webinar to build our own CDN. Software is both available on-premise and in the cloud, and it has become, both for our enterprise version and our open source version, somewhat of an industry standard when it comes to caching and when it comes to HTTP acceleration. We offer it, as mentioned, on-premise and in the cloud, and when you look at the numbers, about 4.8 million websites at this point use Varnish. Be it small websites, large enterprise projects, but also the typical CMSs like Drupal, WordPress, Joomla, Magento. So these add to those numbers. About 19% of the top 10,000 websites also use Varnish. But if you look at it from a historic point of view, people always associate us with web and API. So when we look at the verticals in which we're active, web and API is big. It's people know us from that. And people are always surprised when I mention that we're also very big in DIY CDN, which stands for do-it-yourself CDN, which is the topic of tonight. And video might be a surprising use case, but it's very relevant to us, especially given that about 80% of the bandwidth that is sent over the internet is related to online video streaming. Those platforms need to be accelerated as well. And a fourth vertical in which we're active, that might sound surprising, is web application firewalling. Now, people mostly know that we protect your origin servers from excessive loads, tons of visitors, big traffic spikes, but we can also protect you from malicious requests and potential intrusions. Unfortunately, I do not have the time to talk about all the features, but I can talk about a couple of feature categories that make Varnish relevant to this use case, but also to web acceleration in general. We were built for performance. Now, to throw some numbers at it, on average, we can process a request internally if it is stored in cache in about 30 microseconds. We are very comfortable with processing over 100,000 requests a second per machine. And if all is configured correctly, you can even process 150 gigabits per second on a single box. Of course, these are numbers that were done on ideal setups, but in reality, you always have aspects slowing you down, such as the infrastructure you have, some of the network capabilities you have. So these are not theoretical numbers, these have been benchmarked, but your use case might differ. Another key feature category is persistence. Now, having persistence, having enough disk space for a CDN is very important. You'll see that throughout the webinar. But persistence requires disks, and disks are usually considered the slowest part of your stack. We, however, have a product called the Massive Storage Engine, which tries to go around that does not fall into the typical traps that the operating system sets for you, like slow down in terms of file openings, slowdowns because you have to do massive directory iteration operations. You will see throughout the webinar that we have an efficient way so that you can benefit from the reliability of disk persistence, but still have a lot of power. And personalization happens to be our strong suit. And that's the reason why most people use us and like the technology, is because you don't just get a lot of configuration parameters, you get a full-blown programming language called the Varnish Configuration Language, or VCL as we refer to it. And you also see in this webinar that you can tweak it to your exact needs. Today, we are gonna build our very own CDN. And you might ask yourself the question, why would we build our own CDN if there's so many CDN providers out there? Well, the thing is, the CDN providers provide a service. I have to admit they do it quite well. They may be our competitors, but they're also our partners. We, however, on the other side, provide software. We provide software that can be used to build CDNs. And it's exceptionally useful for people who want to have more control over their delivery flow, or want to have coverage in locations where your typical CDN doesn't have a point of presence. The interesting bit is that you're not sharing a service. You're not a tenant in a SaaS solution. You actually have a dedicated CDN to you where all the resources are yours. Now, in my demo, it won't be so relevant to have the coverage in locations where your CDN provider doesn't have coverage, because I'm doing it in the cloud. And usually the CDN of your cloud is hosted in those same data centers. But keep that in mind. What we also do is we protect your origin from the impact of public CDNs. A lot of these big CDNs have so many points of presence over the world when they revalidate, they might cause a sort of DDoS effect. And for certain companies who already have the infrastructure and the network in place, they just want the software and do it themselves. Now, there's a big difference between serving something from cache and doing an actual CDN. A CDN, when you boil it down to the essence, is nothing more than a bunch of reverse caching proxies, a bunch of caches like Varnish, hosted all over the world. But you will see that only 20% of the effort is related to caching and about 80% is networking. Speaking of which, this is the setup we're going to build today. Now, at the base level, there is an origin server, a regular web server that hosts a PHP website with a little bit of HTML, CSS, some JavaScript, and some online video that will be hosted. Now, it's nothing too special. I will show it in a minute, but we need to cache that. We need to make sure it is distributed globally, and we'll do that in two regions. A European region hosted in Ireland with AWS, and a US region hosted on the East Coast with Azure. And those will be connected by a central point of entry called a Route 53 DNS zone hosted at Amazon that will take the www record and make sure that if you're in North America, you'll be routed to our US point of presence. And if you're anywhere else in the world, you'll go to the EU. You also see the traffic router. That's a separate product of ours that is not hosted in either of those data centers, and I'll showcase it near the end. So let's get going. Let's do it. I hope you can see my screen all right. This is our EU point of presence, and this is where we do what we need to do. I think I have my colleague Ariana here who can share this URL, because the danger of this is that if I play this video for you, it won't do it justice, because this GoToWebinar software, it's very good, I like it, but it's the frame rate and the resolution will make this video look, pardon my French, look a bit shitty. So please have a look at that and play the video if you want to, look at how the page is constructed. But not too much, please, because I have fears that this will crash the application. And that would actually be quite nice, because that's the point. We're building a CDN to protect our origin server. So the first thing we're going to do is we're going to actually set up caching servers. And I am forced to go back to my presentation to show you what I'm going to build. I am going to start off by building two EU edge servers. And I call them edge servers because they're in the edge, as we call it, the outer tier of your platform environment. And that is what will take the brunt of the request. It will make sure that your origin is safe. We'll do two for the sake of distributing load evenly so that we have more capacity, but also for high availability reasons. If one crashes, the other one is still up and running. All of that will be managed to a load balancer, and that will happen identically both in the United States as in the EU. And it's these load balancer endpoints, the US and the EU endpoint, that will be registered with Route 53. So that's how we're doing business today. What I do want to show you before I continue is the composition of this page. This page displays that I am in the EU, and eventually I'm going to present you with a US version, but also this timestamp. And it's very relevant to caching. When I refresh, and when you refresh, you'll see the same on the origin, is that the timestamp changes. That means it is not cached. That's a trick we use. This video you see is using HLS, and HLS is a fairly mainstream streaming technology that was invented by Apple, and that is used by most of the big broadcasters who do OTT solutions. What it does is it takes a big, large video file, it chops it up into bits and pieces, and makes sure that these are loaded separately. All these little segments are then grouped in a playlist, and I'll show you what that looks like. Bear with me. So if I go to the network tab here and I refresh this, you will see this main.m3u8 file. An M3u8 file is this playlist file. And if you look at the response at what is in it, it is just line delimited pieces of information that contain all these little segments. And these segments represent 3 seconds worth of video. And for the entire demo, for this setup, we have 443 little pieces of 3-second video that obviously need to be cached, because after a while, when we hit a lot on it, it might take its toll on the infrastructure. That's what the CDN needs to do. Now, I am going to show you, I'm going to go back and I'm going to play this video for a second. I'm going to clear it now and filter on XHR. So when I play, you can see that all these segments are loaded by my browser. Some of them are buffered in advance, and then it's just a matter of every 3 seconds, a segment is loaded. So that's how we will operate. But it's about time to create that CDN to protect this nice little website. So I'm going to my instances on AWS, and I already have 2 instances there. My origin, which we will need, of course, and this sort of meta service called VCS, which is short for Varnish configuration, Varnish custom statistics rather, apologies. This is a server that will gather statistics from all of our web nodes, from all our Varnish nodes, and we'll present them in a nice dashboard, which we'll do later on. So let's launch some instances. And what you typically will do is pick an operating system like your Amazon Linux, Red Hat, Ubuntu, SUSE, and just install everything. But we're not going to do that today. We will click on the AWS Marketplace button and look for Varnish Enterprise, which is a ready-made image provided by us. We deploy these images to the cloud, and we offer pre-installed versions of Varnish that are maintained. Every now and then a new version comes out. It's actually convenience. And you can use our enterprise product. Our open source product is here as well, both under Red Hat and Ubuntu incarnations. But the cool thing is, if you want to play around with all these enterprise features, you don't have to buy a license up front. So we select it, and then you will see the pricing. So you have whatever Amazon is charging you, and we have an hourly rate on top of that for licensing. So it's flexible. You can get in, you can get out when you want, and there's free trial. So I'm going to use this Varnish Enterprise 6, the latest and greatest of our software. And I am going to select a more storage heavy system here. We're building a CDN, we need lots of capacity. I'm going for storage optimized. When I go lower, I've put my eye on this one here, this i3 2x large, has 8 cores, 61 gigabytes of RAM, and a massive 1.9 terabytes of NVMe SSD storage. Exactly what we need. So I select it, and then we need to configure our instance details. In the diagram, you saw that we need 2 nodes on each side. So let's create 2 nodes. Select 2, carry on. We get a confirmation of our storage, this 1.9 terabytes, and the fact that we have 8 gigabytes of storage available at the root level. Next thing is tagging. I will add a tag, a name tag, so I can identify it in the list. And we'll call this using a fixed naming scheme that we'll use throughout the demo, is DIY, CDN, EU, and then Edge. These are our Edge servers. In terms of security, the next step in the wizard, we don't really have to worry because these ready-made images that we provide already come with firewalling settings under the form of a security group. All the ports are open. 22 for SSH, 80 for web HTTP, 443 for HTTPS, and then a bunch of them for other services that we run that do more maintenance, discovery, high availability, that kind of stuff. All right, it's time to launch. And to confirm that we have this SSH key that I created in advance, and we're launching machines. It will just take a second now before Amazon gives me the confirmation, and then we can carry on the work. Live demos are always a bit tricky, but here we go. They are launching in the EU and Ireland. So as you can see, it's still very much pending, and all the stuff needs to be installed and initialized. That gives us some time to change things. I'm going to rename it and make sure I have Edge 1 and Edge 2 for my convenience, so I know which is which. Then I'll go back to Edge 1, and if I scroll down here in this panel, I can get the public IP address, which I'll need. I'll go ahead and create DNS records, which makes interacting with these machines a lot easier. So I have the second tab that also goes to AWS, but a different product called Route 53. This is our DNS. So in this DNS zone is called DIY-CDN.varnishsoftware.com. That is the DNS zone that we'll play around with, and you already got that link by my colleague Ariana. You see that the origin is here and some other services as well. We're creating a record. We call it EU Edge 1, which is an A record because we're pasting an IP address. And I'm lowering the TTL. In production, you will not lower the TTL, we'll keep it pretty high, but just for flexibility reasons, I'm doing this. I also have a secondary node, of course, Edge 2, which I will create as well. Low TTL, paste the IP, good to go. So that's that. Now they're up and running more or less. We need to wait until they're completely finalized. So if we look at it, they're still initializing, but we have some more work to do before we can carry on. Because if I go back to my slides, go back to the diagram, you'll notice that we need a load balancer. So it's time to create that load balancer. Before I can create a load balancer, I need to create a target group. So we scroll down in this EC2 instances screen and go to target groups, which actually groups our Edge servers. We're creating a new target group. We're doing it on an instance basis, and we're calling it DIY CDN EU HTTP. because this is going to attract HTTP traffic. But I'm not going to go for typical HTTP. I am about to create a network load balancer that is not aware of HTTP or HTTPS. It's not layer 7 aware. I'm going to make it a TCP network load balancer that only knows TCP information. This is a specific choice I've made, and it will be clear in a minute. The next step is associating these two machines, making sure they listen to port 80, include them as pending below, and then it's just a matter of creating the target group. I also need a target group for HTTPS traffic, secure HTTP. So I'm doing DIY, CDN, EU, HTTPS, and again, I'm not choosing HTTP or HTTPS, but I'm choosing TCP, and I'm selecting port 443, which is the HTTPS port. I'm doing this specifically because if I use regular HTTP, I'll be forced to use an Amazon application load balancer, and that forces me to terminate the TLS certificate there. That's not something I'm willing to do. I'd rather terminate the TLS certificates on my machines, hence the need for a network load balancer. So we continue and carry on. Make sure we register our nodes with port 443, include them as pending, create the target group, and we're all set. We can now create a load balancer. Click load balancer, click create, and then, as mentioned 2 times before, we're picking the middle one. We're picking a network load balancer. We're calling him DIY CDN EU, and we need 2 listeners. A TCP listener on port 80 for HTTP traffic, a TCP listener on port 43 for HTTPS traffic. I'm willing to get IP addresses from all 3 data centers in the EU West 1 region. We don't need any configuration settings. And in terms of routing, we are going to select the existing target group that I predefined. So in the list, we're going for HTTP. That will preset all the settings the way we want. And we don't even need to register the targets because they were pre-registered in the target group. Review, create, and boom, we have a load balancer. But it did make some wrong assumptions. So I have to close it here and go back to the listeners of this freshly created load balancer. Because unfortunately, I wasn't given the option to give port or listener 443 the proper target group. So I'm going to have to edit it here. Click this one and make sure I select HTTPS. There we go. We've got it. Now it's just a matter of waiting before the DNS resolution of this domain name has been done by AWS. This is the endpoint, an A record, but we don't want to use that one. We want to use our own domain. So we're going to have to create another DNS record. Going back to this tab, creating a record set, I'm calling this EU. That is my EU endpoint if I want to force entry to the load balancer in the European Union. This is not something that refers to an IP address, but to a host name. So I need a CNAME record, and I'm lowering the TTL again and pasting that endpoint. There we go. But we don't really care about EU dots, whatever. We care about www. So I'm going to create that record as well. www, that's the endpoint we're going to play with in a minute. And that as well is a CNAME. We're lowering the TTL, pasting this one, but before we continue, we have to adjust the routing policy because this is where it gets interesting. This is where we make the distinction between US and non-US traffic. So I'm going to go for geolocation routing. And then it's a matter of selecting which region you want to attach yourself to. I could take Europe, but I'm not going to do that. I'm going to go for default because this is very much a failover region. This is where anything else goes to if it doesn't match anything. So if you're in Asia Pacific, you'll end up here. But the goal is if you're in the United States, you'll end up in our other one. There we go. Speaking of which, so back to the slides. I created something in AWS for the EU, which I still need to configure within the boxes, of course, but I need to create an entire point of presence, an entire region in the United States. And this is where we get back to the cooking show analogy. We can't do everything live. It would take a lot of time for me to set that up again on Azure. So if I go to my Azure panel right here and I refresh, there's nothing there. And I won't create it manually, I'll automate it. And I made some preparations where I'm going to use a technology called Terraform. And Terraform is an open source, vendor agnostic cloud orchestration tool. It integrates with all the big boys. And I've prepared some scripts to automate the US setup. So allow me to show you what is going on here. This is sort of descriptive language in which I define what I need on Azure. So I need an availability set. I need my Edge 1 server with all the configurations here, the sizes of the machines, usernames, SSH keys, disk sizing. The same for Edge 2. I have some networking stuff going on as well. So all of this is instrumented by these scripts, and I will run this right now. So the first thing I need to do, I'll clear the screen for your convenience, is to do Terraform plan -out plan.out. So this will plan a deployment. It won't execute it, but it will do all the planning. It will configure and connect to all the APIs that it needs, and will make sure all the deltas are made. As you can see, it also connects to AWS, because in the end, it will need to create DNS records for whatever it is creating. It will take a couple of seconds, and then we'll see what we need to create. It won't take long, bear with me, there we go. 27 actions need to be taken to build an exact replica or almost an exact replica of what's happening in the EU. So it ranges from a virtual network with a specific address space to subnets that we need, IP address information, network cards. This is a firewall setting. And if we go all the way up, we could even see our origin server that will be created, our Edge server. So everything is there. Let's do this. Terraform, apply. And this is where it can all go wrong, ladies and gentlemen. It will connect to all the APIs it needs to connect, and it will instrument all these changes. Bear with me for a second. The last time I ran it, there was a bit of a delay at the Azure side, but as you can see, it is creating everything it needs to be creating. So let's go back and let's talk about VCL for a moment. What I'll first will do is I will deploy the VCL files to my nodes. So what I'll do here is I have this script called deploy EU Edge. It will deploy my VCL file to 2 of the Edge servers, and that same VCL file will be preprocessed and used for the US as well. So let's do it. Let's have a quick look. There we go. We are inside EU Edge 1. I'm opening up etc varnish default.vcl, and that will show me the VCL file. Now, I could spend like half an hour talking about this, but I won't. So what I will do is briefly explain what is going on. First of all, it will import a bunch of modules. These are Varnish modules. These are modules we mainly maintain, and they add functionality to the VCL language. Everything you see here is VCL, the Varnish configuration language. We're importing a standard library of utility functions. We're importing an HTTP module that will allow us to call HTTP endpoints from within VCL. This is MSE, short for Massive Storage Engine, which will allow us to reroute specific objects in specific parts of the cache. So we can choose store it on disk or in memory. This is MMDB, short for MaxMind database. MaxMind is a company that provides geolocation databases. So we get a database from them, and it associates public IP addresses with their location on the globe, which will allow us to do geo-blocking, geo-fencing, geo-targeting, and what have you. This is our throttling module, which allows us to squeeze the bandwidth a bit for users who are misbehaving or users who might not be the ones we want. And finally, we have YKey, which is our cache invalidation module. This is a definition of a backend. This is how we define that requests coming into these Edge servers need to be rerouted to the origin if the objects aren't stored in cache. As soon as the origin responds, we'll store it in cache, and we no longer need to connect to the origin. VCS, so short for Varnish Custom Statistics, this is what we'll use to reroute traffic to our VCS server, and that will present nice API time series data that we can use to visualize in our web application. This includes and this abstracts lots of the complexity behind our high availability suite, which will synchronize content between the 2 Varnish servers. And the VCL language is not necessarily a top-down programming language in which you define everything. There is standard behavior, and VCL allows you to extend that standard behavior by hooking into the so-called finite state machine. You can extend those states. This is an initialization. Ooh, that was a tongue twister, an initialization stage, where we initialize a bunch of our modules. First of which is the MMDB. We will load the database where the geo-IP information is, and we'll present it as a geo-IP or GeoDB object. Next up, we're configuring a couple of settings from VHA, from Varnish High Availability. There's a bunch of those to configure. We only configure 2. A token, secret token, that is used to encrypt the transactions. Please pick a better one than I just chose in production. I chose secret 123. Next up is defining which servers should be synchronized. I'm choosing EU Edge, so within this region, I'm only synchronizing to my other node. This VHA6 relies on a tool called Broadcaster, and Broadcaster is a utility tool hosted on this machine, ships with the image, and that allows you to broadcast messages to multiple nodes, which is convenient. Let's say you want to invalidate something or you want to warm up the cache. This one will allow you to do a simple call, and it will distribute it to all nodes that it knows. These nodes are listed in a nodes.configuration file, nodes.conf, and this serves as a sort of grouped inventory, which you will see in a couple of minutes. This EU Edge group contains both of our Edge servers, and there's also a US Edge group. Then you call this one, and high availability works. For those of you who have ever played with Varnish, will probably recognize this one. This subroutine, as sub stands for, hooks into the receiving logic. So whenever a client connects, we receive a request, then we can start extending the behavior. The first thing we'll do is we'll introduce a new request method called purge. Purge usually doesn't exist. We know get is the way we interact with HTTP, and when we want to change something, we use post. When you use APIs, you can use put or patch or delete. Now we're introducing purge, which will allow us to delete content from the cache. It's also fairly interesting. So when you call a URL via purge and you don't do anything special, you can see this here in the else clause on line 36, it will purge it from the cache, which is very important. Let's say you have some breaking news on your website, but it doesn't show because it's cached. Well, this will allow you to do that. But if you need a little bit more flexibility, YKey has you covered, because you might have this widget on your website that appears on 100 different pages. Knowing all URLs can get tricky. That's why this YKey method, or this YKey header that we're introducing here, will allow you to invalidate based on tags. And near the end of the presentation, I will show you how that works. VCL has a request object here that has all the request information, and it contains an HTTP property that has all the headers here. So YKey purge is a header that you pass, custom request header that you pass, that contains a tag, and all the objects that have been tagged with that tag will then be invalidated. As you can see, it will do YKey purge based on a header. You will pass the header and it'll be gone. Now, how do you associate these things with tags? I will show you in just a second. Maybe I'll show you right now. So if I go back to the browser, to my origin, and I inspect, whoops, that was not the goal. I inspect, I go back to network, I click doc and refresh. You can see the headers. So I click headers, and one of these headers, as you can see right here, it's called YKey. And what we're doing here is we're adding tags. This is a page, and this is part of HLS. And when you invalidate it based on a tag, you no longer need to know the URL. It will invalidate everything that is associated with either of these keys. Very convenient, and I'll show you how that works near the end. Let's carry on. This line here will indicate that whenever a request is received and something should be looked up in cache, it should look at this backend called EU origin. That's the one we defined right here. But we need to carry on. Here we're storing the country code and the country name that we detected using that MaxMind database that we call GeoDB. It gets the country code and the country name based on the client IP address here. And it stores it in this custom request header, which gives us the opportunity to show you a couple of features. They're more hypothetical. In real life, you'll do it differently, but we're intercepting requests that go to geoblock. And if you go to /geoblock and the country code is not BE, as in Belgium, country I live in, or IT, Italy, country my colleague Ariana lives in, you will not be able to see this content. And we'll be throwing in a synthetic piece of HTML. Synthetic meaning that whatever you're seeing originated from Varnish directly and did not originate from an origin server. So what we're basically saying is content is only available in Belgium and Italy. We've located you in, and for a lot of you, that will be the United States. If you do geoblock 2, when we reach the point where we'll demo this to you, that's the exact opposite. That will only work in the United States and will not work for me, nor will it work for my colleague Ariana. Here's our rate limiting feature. So if you go to the rate limit URL, mind you, this tilde sign is matching a regular expression. So you can match regular expressions here. So if we go to /rate limit, we identify ourselves here with our client identity. And if more than one request per second on that URL is sent, you'll be blocked for 5 seconds with a message too many requests, which is the equivalent of a 429. We also have prefetching capabilities that allows us to guess the next segment. This prefetch next URL is quite convenient in this context, because if you go back to the video player, you'll probably remember this. If I play the video, all these URLs are sequential, they're numbered. That's why we can guess them. So what we can do here, if we see a request coming in via prefetch, and prefetch next URL can guess the next one, it will already fetch it, store it in cache. So by the time the video player needs it, it comes directly from cache, and there's no latency at all. This is more boilerplate stuff. I'll skip over it, and I'll go to something that actually matters. Sub VCL backend response is a hook where the backend responds, as the name indicates. That happens when something is not stored in cache and when the backend was fetched and it responds. The first thing we're doing is that Y key header at our page return, we're intercepting it, we're looking for comma space delimited content, and we're tagging it. We're also tagging every piece of content with the all tag. So if we want to flush the entire CDN, it's just a matter of invalidating the all key and all of it will be gone. We're doing some bookkeeping here, but what really is interesting is this part. When we receive a response from the origin server and we want to store it in cache, we check what the URL was of the equivalent, the corresponding request. So if that request URL that triggered this response matched the regular expression ending with M3U8, we're basically dealing with an HLS playlist file. So what we're doing here is we're tagging it as HLS and tagging it as playlist so we can invalidate it when we want. We set the TTL of the BRESP. BRESP is short for backend response. We set the TTL to a second. That means Varnish will cache it for a second. The reason is because M3U8s are also used for live video. So if you decide to host live video on there, that playlist file is constantly updated. So we need to make sure that it gets invalidated in due time. We also select not to store it on disk, set stores none, because it's so short-lived, after a second it will be invalid, so no reason to persist it. And we're marking it here as memory store. However, for TS files, the transferred segments, this is the binary video content. These are a bit bigger in size, and they're also HLS. We're tagging it as HLS and TS. And because they're so important, and because they process so much of our bandwidth, we want to cache them as long as we can. So we're caching it for a day. And because this machine will have plenty of disk space, we'll be absolutely fine. It's a two-layer system, so the hot content will be served from memory. If this one doesn't happen to be in memory anymore, we can comfortably fetch it from disk because our disk solution is quite fast. We force it to be stored on disk. We debug, send a debug header to say so. And for every other piece of content that we can't identify, we'll also persist it to disk and do not touch the TTL. It's up to the cache control header that the application or whatever platform it uses sends that we will respect. And that's VCL. There's a bit more here, but let's get out of this situation. Let's have a look how our US setup is doing. And by now, hooray, we have finished it. Our US solution is working. I'll show you in a minute. What we'll do now is we need to log into those machines and set them up. So I've prepared a little bit here. We'll need that. And I'm going to open up the necessary scripts to run this. Just a second here. All right, let's go. I have two terminals here and the content is mirrored. So that means if I type a command, I'll be absolutely fine. So that means on this screen, I will access server edge 1 and server edge 2. Every command I type will be duplicated on both. So if I type clear here, it's cleared. And I will run a bunch of commands, the commands we need to set up Varnish. I told you about that Maxmind database. Well, it's about time to download it. I stored it on my Dropbox. I'm downloading this tar.gz file, and it happens on both machines. Then it's time to extract the tar.gz with this command, and boom, in TMP, we have that Maxmind database. Now, I will not keep the screen as wide. By now, you probably trust me that the content is there, so I'll minimize it to have more screen real estate. At this point, it is time to set up the infamous massive storage engine. I talked about it. I talked about the persistence layer and about its power. Well, this is the configuration file. If you pay close attention, we're pasting this content to etc varnish mse.conf. It is a configuration file. And we're defining our environment as myenv. You can probably find a more clever name, and setting the memcache size to auto. This is a feature that has been available on Amazon for, I think, 2 days ago, because this is our latest release, Varnish Enterprise 606 R5, and it contains the new feature called Memory Governor. Memory Governor does dynamic memcache sizing. So by default, if you select auto, it will allocate 80% of the memory on this machine. I think I have 61 gigabytes on this machine. I guess about 48 gigabytes will be allocated to Varnish. And it will act accordingly, scale it out, scale it in, make sure there's harmony. But we also have books that contain stores. And these stores are the data stores where everything will be stored. As you can see, these are single files, pre-allocated large files. Data MSE store 1, data MSE store 2, and they're a whopping 900 gigabytes in size each. This is the mechanism we use to avoid slowdowns in terms of the file system. The file system on an operating system is relatively slow. Opening up a lot of files will slow you down. Iterating through large directories will slow you down. And eventually you'll create disk fragmentation. And we're avoiding this. We just pre-allocate a single file and we just stream all the data through that file that we want to persist in a very intelligent way. We're tagging it as well. The default tag is none. You've seen that for these M3U8 files. You're referring to that none tag, which is memory-based. And then I associated a disk tag. You can specify more tags if you want to. This is MSE. Here we go. We've set the configuration file. It is there. And it's about time to set up the disk. When creating the machine, Amazon notified me that this dev NVMe 0N1 is the device, the storage device, where I could have 1.9 or 1.8 terabyte available. I'm formatting it with XFS file system, and I'm preparing the mounting point. I will mount this on /data, so I need to make sure that /data exists. Let me clear it for you again, have some more screen space. What I will do now is I will mount this with the mount command. There we go. It is there. And if I do df-ah and I grab for data, you will see that I have this /data mounting point with a point, 1.8 terabytes of storage. Good to go, I'd say. But I also need to create the MSE folder within that data partition to make sure that that is a place where MSE will be stored. And finally, to initialize MSE, I have to run the following command. And this command is an mkfs MSE. It's a custom binary we ship, and it will read the contents of that configuration file and make everything happen on disk. And as you can see, it created the book in this location. It created the store on this location, and it created another store there. And I can actually have a look at this right now. If I do ls-lh of that pod, you will see these 900 gigabyte files. So that is good. We've set up that part. Next in line is our nodes configuration. We need to make sure that all the full cluster is aware of all the machines. So I'm storing this in etc/varnishnodes.conf, and it contains the grouping EU edge, US edge with all my nodes. There we go. And the broadcaster, that service I talked to you about, which I will show in a couple of minutes, will use that to know where the route requests to. You probably also remember, because I mentioned it 4 times, that we create a network load balancer, not an application load balancer, because we wish to terminate TLS locally. Well, it's about time to do that. So if you need to terminate TLS, you need TLS certificates. Here's a bunch of text that represents PEM-encoded TLS certificates hosted in the place they need to be. The next one is a bit boilerplate-ish as well. I am putting in an HTML file that is nicely styled with the same styling elements of that page to make sure that if Varnish spits out an error, it does this in a more HTML styled way. What will happen is that reason placeholder word here will be replaced. There we go. Next up is making sure the VCS agent is extendable. So we're doing some systemd magic here, and we're making sure that the VCS agent logs to that, doesn't log to localhost. So I'm doing a find and replace where localhost will be replaced with VCS DIY Varnish software. The stats need to end up there. The next thing I'll do, and I'll do that manually, is to open up an override file by Varnish where we'll select which storage we'll use. So systemd system, then Varnish service override. And right here, you're seeing that Varnish is listening on port 80 and that it has this proxy setting to take in terminated TLS connections. But what bothers me at this point is that I only have 1/4 of a gigabyte of memory. We're not using typical malloc, we're using something faster called MSE, Massive Storage Engine, and we have this etc varnish mse.conf file that we need. So we're done with that. Time to restart all services. And this is it. We've just set up a multi-region, multi-cloud CDN, and it just takes a little bit of time for the load balancers to kick in. And now we can spend, I think, the remaining 20 minutes on features, which is nice. Now you set it up, now you need to see the behavior. So at this point, I'm going to the browser, and I'm really, really hoping that if I remove origin and just have EU, that it will work. And it does. Ariana, will you be so kind to share the EU endpoint? Or you already shared the origin one. Please share the EU one, the load balance one. And please, by all means, have a look at that URL to make sure that you can see that it is cached. So when I refresh at this point, it is cached. And how do you know? Because this timestamp doesn't change. And then you can start playing the video and everything will be fine. So all is good. We have this set up. But what I care about more is about the www, if that is working. So I'm setting up www, and it is registering in the EU. Now I need to do something tricky. I have another colleague here called Alexandra, who is based in the United States. So I'm going to give it over to her, and she is going to go to the very same website, to that www DIY-CDN. Ariana, will you? I'll paste it for everyone here. Can you paste the www without the EU, please? In the last thing you pasted, Ariana, you still have the EU in there. Yes, there we go. So Alexandra, please go to that one, and I will hand the screen over to you if I can. There we go. Would you be so kind to take it over and go to www, share your screen. There we go. And she is going to the very same webpage. Please play the video, yeah? Don't mind if you do. And that is US. So we are going to exactly the same website, but we're seeing different content, which is nice. That's the point of the CDN, right? So I'm happy that this has resolved. And if I wanted to, I could end it here, but there's a little bit more features that I wanted to show. So can you please give it back to me, Alexandra? Let's see if I can share my screen now. There we go. And we're back in the EU. Let me debug what's going on. That might be interesting to you as well. So I have a shell right here. Let me take that shell. If I do a curl, which is, for those who aren't familiar with curl, just an HTTP browser, but on the command line, curl -i-s. I'm going to that website. I'm getting a bunch of headers. I'm really interested in the headers. And I will sort them alphabetically for your convenience. Just a second. What I'm seeing here is an H header. So it has been, this page, this home page has been in cache for the last 183 seconds. And it can be in cache for an hour, for 3,600 seconds, because the application sent a custom SMAX H cache control header with 3,600. Because this is a regular page, it's not a TS file, not an M3U8 file, we didn't override the TTL. So VCL allowed cache control headers to dominate how long things should be stored in cache. There's more useful input here. Look, this X country code located me in BE, which is Belgium. And the node I'm currently on is EU Edge 1. So the load balancer sent me there. I'm going to already copy this. And the origin that it originated from is the EU. And this X storage header says this is stored on disk. So if I would change this to HLS main.m3u8, you would see that this would be stored in memory. Another thing I will do right now is I will filter based on the storage origin, or the edge origin rather. So I'm doing the same request again. I'm on edge 2, doing it again, edge 2, edge 2, edge 1. So you see that the load balancer randomly picks nodes. So the load is distributed between both, which is kind of interesting. I also told you that there's high availability in there. I want to quickly show you how that works. And I'm going to do this by filtering for an age header, by explicitly going to my primary EU edge, so EU edge 1, and I'll be calling a URL of which I'm sure it doesn't exist in cache. So let's say I'm going to blah, EU edge 1 blah, I'm grepping the age, and the age is 0 because it was a miss, it wasn't stored in cache. When I refresh it, it will be in cache. It has been for the last 4 seconds. Now, I'm also positive that I didn't do this on the secondary edge either. So I go to edge 2 and I again filter on the age. The age will be 16. So that means in the meantime, while I was fetching that non-cached content, Varnish also synchronized it to its other node, which is very convenient. That is high availability for you. Another thing I wanted to show you is Varnish Live. That will measure and monitor the performance of what we have here. So Varnish Live is a web application, but it's also a mobile app. So it's available for Android on the app on the Google Play Store, and it's also available on the App Store of iOS. It's a nice dashboard service that actually leverages this VCS thing. So if I go to data sources, uses local storage to store this data source on my computer, and it points to the primary EU edge to that URL, which then talks to VCS. So if I go to the main overview, we can actually start throwing some load in there. So please, ladies and gentlemen in the audience, please go to your www and maybe click play on the video. I know I will. So I'm clicking play on the video and I'm watching it increase. Look, 65 megabits, 42 megabits. If you look at the request rate, oh, we're spiking a bit. So at this point, we have an 28 requests a second. These are large files, by the way. So you won't have that much files, but you do have a lot of bandwidth. Are there errors? Not really. How many unique users have we? About, 13 or 14 at this point. But what I really care about is the transfer rate. Like we had these spikes to 140 megabits per second, and now we're pretty stable here. What I'm going to do now is I'm going to cause a massive spike, and I'm going to use AB, which is Apache Bench, which is a benchmarking tool. And I will unload 5,000 requests on it with a concurrency of 40. I know my laptop here can't handle that much, but I'll send out as much as I can. And you see the traffic absolutely spiking here. It has a bucket size of 2 seconds, so every 2 seconds the new data comes in. When you look at here, you're like 250 megabits. Now, our environment can handle quite a bit because we have 10 gigabit network cards, so we're absolutely fine. And with the bit rate of 3.3 megabits on that video, we can easily process 6,000 requests a second on this one. And this is a small setup, mind you. So I'm going to stop doing this and act normal again, and you'll see it drop to 85, and it will gradually go down. I'll stop playing it here. And what I'll do next is I'm going to show you that GeoBlock feature. So if I go to GeoBlock, nothing is wrong. Ariana, will you please share GeoBlock with the audience, that GeoBlock URL? And please try it. Like, if you do this and you are not in Belgium and you're not in Italy, you won't be able to see it. So everything is fine. For you, it might act weird, but I'm going to show you what I'm seeing when I'm doing the exact opposite by going to GeoBlock 2. And please share GeoBlock 2 as well. I'm not in the United States. So if I refresh this, this is synthetic output coming from Varnish telling me that I'm not available or not eligible to see this content because I'm in Belgium. Now, this is computing stuff. This is decision making that has been done on the edge. Our PHP application with the video has nothing to do with this, which is quite nice. The same for rate limiting. If I start rate limiting, then if I do it fast enough, all of a sudden, too many requests, and I'll be blocked for 5 seconds. So all these features are part of that. Now I have another cool feature here that I haven't showcased you, but that is part of our slides. If I go back to my slides, on the top, you see that gray box, the traffic router, which is a product I haven't talked about. The traffic router, as it indicates, will route traffic to the right destination, and will do this in a very fluent and efficient way. It behaves a little bit similar like the GeoDNS because it's geo-aware, but it doesn't use DNS because DNS can be tricky. It's a distributed protocol, and you might have some issues with back caching in your own DNS server. This system uses redirection, 302 redirection, and it comes with a panel. Let me go to the panel right now. So this is now hosted in our own data center, single sign-on. And you can register host names that it needs to match to. I already have that. And what it will do, and this is just software, and mind you, this is unreleased software. This is a project still in the works, and this is a preview I'm giving you of something we're going to release at some point, which is excellent for video, mind you. So router DIY CDN varnish software.com is this endpoint. When I click it, and I will increase the font size maybe for your convenience, I have two endpoints attached to it, an EU and a US. If I go to the settings, this EU endpoint will point to that EU load balancer. And it uses the same endpoint for health checking. And it's enabled, and I'm associating this with the EU. I have an equivalent in the United States, US does very much the same thing. Now these are tagged to EU, tagged to US, tagged to full fallback. And then we can associate rules with the same tags. So I have this US tag that is associated with the following rule. If we notice that the continent of the client accessing this service equals North America, well, then you use the US tag, which will then point to this endpoint. The same for the EU, no surprises here. If it's Europe, then you go there. And in all other cases, you use a fallback tag. And in this case, the fallback for me is the United States, but we'll play around with that. If I go back to my main website, and I will share or ask Ariana to share this, it should be using the traffic router. So let me have a brief look. Let me inspect. I go to network. I play. I'm not too sure what's happening here right now. Live can always kick your ass, right? Okay, it's happening. It's happening. So what happens here is that you see two of these 018s. That is not normal as would be, right? But the first one comes from the router, as you can see here in the label, and it redirects you. So let us try that one. So I'm gonna copy the link address of this thing here, and it points to router.diy/cdn/h, the full URL, but with a different namespace. So if I do curl -i-s to see what's going on, when I go to this endpoint, which will point to the traffic router software you've seen, it won't show it directly, but it will check who you are, and it will redirect you with a 302 found. And it will use that endpoint, this EU endpoint, to send you over there. And it could do that on the fly. Whereas DNS has some time to live, of course, this one will do it like on the spot, and I will show you how that works. And it does a lot more. Like it tries to identify where I'm at. I'm in Europe, that is correct. I'm in Belgium, that is correct. I'm in a city called Storhout, well, close enough. Like that's like 10 or 15 miles from where I live, and it will do that. If you were to be in the United States, it will do it differently. So please, Ariana, can you share the router as you've done? And what I will do now, like you could try this, it should say US. And another thing you can try is you can do the same, even if you're in the United States, on this EU endpoint if you want to. So if you go to eu.diy/cdn-varnish-software.com/router and you are in the United States, the video will still be hosted in the United States, whereas the page will be loaded from the EU. That might not make sense to you, but I'll show it how it works with me. So I'm based in Belgium, EU, and if I go to the US page, I'm seeing US origin, so this is very much the US page. Let me increase that font size for you. If I play, the content will still be from the EU, which is just kind of nice because the traffic router is that intelligent. And what I'll do now first is I'm gonna pull the rug on EU and I make sure it switches seamlessly to US. So I'm playing the video, all is good. And I'm going to the traffic router, and all of a sudden I'm going to disable that EU rule so that it no longer is active. I update it, and the traffic should be rerouted to fallback, which is the United States. So when I go back here, nothing spectacular happens because it is buffered. And I will try to fast forward just to the point because there's some buffering happening. See, the label switches here, so let's do it. I'm in the EU, all is good, bear with me. And now I'm in the US, and it didn't even glitch. The video quality remained excellent, the flow of the video remained excellent. And that is what the traffic router can do for you. So It's unreleased, but it's really promising in a DIY CDN solution, especially for videos. Because it does redirects, as you see here, might not be ideal for websites because of SEO reasons. So that's basically it. I think we've reached the end of the presentation. I have 5 minutes left, but I still have a little bit of housekeeping to do. So I hope by now, we said, let's get it started. I hope you're convinced that we can build a CDN like that.
Perfect. And with that, I would like to thank Thais for a great presentation and phenomenal overview. I would also like to thank Varnish Software for providing the audience with a great webinar. Thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Thank you and have a great day.